Hi, so I'm Surbhi. I work at Google here in New York, and I've been working on the Maps team for like the past 8 years. Um, I started on the Android front end side where I spent a few years, and then now I'm kind of mostly in the back end side of things, but I've been all over the stack. So today we're going to be talking about server-driven UIs. This is not a deep, like technically complex talk. It's more of an overview of what it is, when you should consider using it and when not, and just some trade-offs to think about in this space. Um, so uh, this is just a little bit about me. I do other things except work. And if you want to connect, feel free to reach out to me on LinkedIn. Um, so, brief outline. Um, First of all, we'll start with a little origin story of how server-driven UIs came to be, even in the pre-mobile era. And then we'll discuss an architectural overview, walk through some kind of popular examples that have been published in the wild to illustrate what a successful system design for this could look like. And then the key thing really is discussing when it is a good idea to go down this path and when it's not. But for that, I think it's nice to understand how it actually works and the complexities in designing such a system. Um, so, server-driven UI has existed since the days of when dynamic websites initially came, and PHP scripting became a thing, and you could send HTML from the server instead of putting it like statically in the browser. When we had PCs and you were just hooked onto a good internet connection before the mobile era, then JavaScript solved a lot of interactivity issues, and client-side rendering was kind of the preferred way to do that. And now we're in this age of complicated bandwidths and poor network connections and different mobile devices, all of these things. So things are kind of trending towards more server-driven UI in some instances too. So it's all cyclical. What comes around goes around again, kind of. So brief architecture overview. This is oversimplified, of course, but how it basically works is that the client for a particular request and response API rendered via server-driven UI, the client is just a thin layer that takes a UI template and data model created entirely on the server and just renders it without knowing what it even is. So there's not much going on the client except just trusting what's coming back in the response, which means all of the business logic for both data fetching and actually laying out the UI is in the server in this case. And so three main components to do this are having a robust standardized design system defined on the server that can be interpreted by different clients. If anyone went to the design libraries or design token talks earlier, that's what it is. And then the data model is designing a good data model. If you're doing server-driven UI, is probably the most important API design task that you can do. So that is something to pay good attention to if you're going to do this. And then the UI templates also written out in the server, and the server basically will have both the data and the UI, and then combine it, send it to the client, and the client does nothing but just render whatever it gets. This is obviously simplified. We'll go through some of the components in a little more detail. So examples of standardized data models. Why it's important to think about this more carefully when you're designing it is because you don't want to be tied to like a data model that's coupled with a specific UI design. So your initial use case might be like a card with one image and one title, but it's better to be more flexible and have smaller components that you can make a card out of. And then if you decide you want like 2 images, you can do that, and they're all the same type of component. So that's something to keep in mind when you're designing your data model layer. And this is like probably the most important design decision you will make. So while this example is simplified, just, you have to be careful when you're doing these. So standardized design system, design tokens are like a concept that exists for enabling these things. Basically, it's just means a variable that refers to a specific like decision. So you can have a font token that you send to different clients, and then maybe on your Android client, the font token is interpreted as like Comic Sans, and it would just handle that. And then maybe on an iOS client, it uses some other font. Yeah, so it's just like variables used to map to specific design decisions on clients. And this way, the server will just send like one font token for maybe this button font, and clients should know how to deal with it. So that's the second piece here. Another important aspect of server-driven UIs is handling versioning. So this is tricky because this can cause all sorts of skew issues if not handled well. Basically, you can be sending, because you're sending UI templates from the server, you could be sending things that clients just don't know how to handle yet, and that can cause weird behaviors or missing things, etc. So when you're writing UI templates, you have to make sure to support fallback behaviors. So in this very contrived example, you maybe have a card component that renders with a background gradient, but maybe some of your clients or your older clients don't know how to handle like rendering gradients yet. They should gracefully fall back to some other card type that doesn't do gradients. So if you just try to render something without checking for support capabilities on native rendering, it could just like look broken. So that's what skew is basically. This can cause all sorts of weird things, including like crashes. If you try to send back click actions for like what happens when some particular button is clicked, if your client doesn't know how to handle it, it could just behave poorly or be unusable. You can have entire components missing from the page. Maybe the gradient card is just missing entirely, and that would be broken. So just, yeah. And the most common thing that goes wrong is just inconsistent styling. So be wary of skew. And another important aspect that I forgot to add to the architecture overview diagram is actions and event handling. So obviously a key part of UIs is handling like click targets and things like that, or user actions more broadly. So usually how people do it in like server design UI style systems is you would have a set of standard actions defined. So maybe like open a specific page is a standard action for your application. And these actions are also sent along with the template and data to the client. But of course, whenever you add a new action, you do have to add client capabilities and hooks to actually handle that new action on all of the clients that you're serving. So usually what happens is, as a designer of a server-driven system, you will have a library of standard actions that you start with initially, depending on your use cases. And then, of course, if any of the features have specific custom things that don't belong in a library, you can do it, but it would require client changes. So opening the screen is given the ID of a page or a screen is like a simple action. And in your template, basically, it'll be like, here's a button template, and you can define on-click, open screen, and then the client hooks should know how to open it, depending on what the client is. So the response API usually in this system is just, it seems pretty simplistic. It's just, basically it boils down to screens or pages, and then sections within those pages. So sections are your Lego block UI components that screens can be composed of. Yeah, and like the server needs to deal with like how these sections should be rendered in different configurations, including like localization and all of these things. And then any given screen is just a specific list of section blocks that are laid out in some manner. So that's the gist of, high-level gist of the response, screens and sections. So we'll talk about an illustrative example here. There are many popular applications in the wild that have published detailed like engineering blogs on if and how they used server-driven systems and how that went for them. So this is one example that I found pretty fun, and it like maps really well to the generalized architecture of screens and sections that I think most other examples I found do. It's the Airbnb listing page. So this is an overview. This doesn't make too much sense yet, except like just keeping in mind what the sections of this page are. So you'll have like images, you have the place title, the place details, some text description, and then some buttons in the footer that can do things like book and stuff. So the response schema just boils down to a list of screens and a list of sections. There is other metadata in here for logging and maybe monitoring and things like that, but we'll just focus on the actual functionality for now. So it's pretty simple. But what is in a section and what is in a screen, that's kind of the fun part. So if you look at the section schema, you can define all of these generalized Lego blocks. So you have the image section, which just handles like a list of images. And then you have your title section. And you can see there is a click handler on it that will do something if you click on the title. And then these, in this case, are sent back in the response wrapped in a section container type that has an ID and the actual section. Something I haven't talked about yet is like the section component type that they define. That actually controls how the data is actually rendered. So the section itself is just the data and maybe some styling hints, but the actual layout is mapped to by a component type. And the reason for that is because you may have two different screens that want to render the title differently, but you don't want to send the actual title data back twice because it causes response bloat. And things quickly get slow if you send back too many things from the server response, given that it already has UI templates and all these things that you wouldn't be sending in a more client-driven system. So deduplicating sending actual data is very important. So basically, there is a 1-to-n mapping between the actual sections, which contain data, and the component type. And so in this case, these are two different ways a title is rendered, but they're backed by one instance of the section data. So that we only send it back once per response. And then here's a sample screen schema from the response. So this has a little, unlike sections, which should be isolated components that can be kind of put anywhere on any screen, screens have a little more layout information. So these are like form factor things, and you can have, so we'll talk about the layout interface next, but you can basically specify different layouts for like landscape, portrait, or whatever other like client screen density or form factors that you want. So all of these things have to be sent back with screens because it should be renderable in these different configurations. So here's an example of layouts. You can define some concrete layout implementations. So single column is one layout where you just have 3 sections laid out in a single column. That will like render on your standard phone screen. So, and then of course each section also has an ID, and we'll talk about why unique IDs are also important in a bit. But basically, you can have like single column layouts, multiple columns, whatever, all possible layouts that could be used in like portrait, landscape, etc. Whatever you need to support has to go with the server response. So defining these interfaces is part of the schema design. So here are some, actually, before I go to more examples, I said I would talk about unique IDs. The reason we want to send unique IDs are also for response deduplication. They can be used to point to specific data models in the response so that you're not embedding the entire response for each section, component, and screen, etc. And this is because avoiding response bloat is important. So we use IDs to kind of point to other things in the same response. So there are many more examples. I think a lot of apps are doing some level of server-driven UI. Here's Duolingo's kind of components outlined. We have Reddit, and if you look at their old response, it's very tied to a specific UI with exactly the layout that should show up, and the new response is more modular, composable, and what we talked about in data model schema design. So yeah, many examples. Here's another that looks pretty similar. You have like a screen with different sections or components, blocks. Yeah. So this all seems pretty enticing because if you put UI templates on the server and render them on all clients, that means you only need one rendering code base, which seems great because then you don't need to implement all of your rendering on all of your different mobile clients. But there are some things to be aware of, and it doesn't suit every use case. So this is sort of something I discussed earlier too. Be aware of the like God object component, where if you start to design your data model too coupled to one specific UI, you will end up dumping more and more things into the same kind of component. So, you add a card, you put one image, and you put one title, and then you just put like everything in the same card. So break it down into slightly smaller chunks of Lego blocks, and that way you can compose it in different ways, and it'll be easier to keep response deduplication and send things only once. And then related to design tokens, also, don't put client-specific logic on the server when you're building your UI. So don't do things like if client is Android, set this font, else set this other font. That defeats the point of having one UI template on the server. This is where we use a system like tokens, where we send one token and then have different mappings and different clients to handle them. And response payload size, which I've talked about a little bit before. Network latency and performance quickly start taking a hit if you start sending like a button template every single time there is a button on screen. So a few ways you can avoid response bloat. If you have like a really long scrolling app, like maybe a social media app or something, then try to use pagination, so you're only sending chunks at once. And then, of course, for each block or component, try to send only one instance of the rendering template and use a robust ID system to refer to things in the same response. And yeah, these are just some ways you can send smaller responses so that things load quicker. When to not use server-driven UI. If these are your options and you have to think about when which thing fits, few broad guidelines. If you have complex animations and transitions like map panning and zooming, or like you have a game where characters are bouncing around and you need these like fluid animations, native app rendering engines are usually a lot better at doing them and giving a more fluid feel on various network bandwidths. So in that case, server-driven UI is like over-engineering and it's probably going to be slower. So if you have these use cases, just rely on native rendering and it'll be better. And obviously, because you're sending things from the server, if you need to support offline functionality or you want to show some things even when there's poor network, maybe you want to show a more pared down UI if there is poor network, you still need to bake in all of those things on the client for offline support. So designing around what kind of offline support your app needs, if any, is also a consideration. And for static or rarely changing screens, because there's a lot of upfront complexity involved in designing a good server-driven UI system, and it kind of also changes the way maybe your like team structure functions from like iOS devs and Android devs and things like that to like everybody develops UIs in the same code base. That is a consideration where like if you only have static screens like a settings page or things that don't change very often, or you don't run UI experiments very often, then maybe it's not worth it to change from whatever you currently have. So to summarize a few takeaways between the two approaches, these are kind of the like things that one approach is better at than the other. Obviously, server-driven UI is great for quick A/B testing, bug fixes, pushing out updates without relying on waiting for your users to update the app or pushing out a new binary release for your app. So if you do a lot of that, then it's a great option. Obviously, client changes will need to wait for the next binary release, and then you have to wait for users to update the app for them to get the changes. And then there is, of course, response processing and rendering time. Server-driven UI is pretty quick on good networks. You get the fully formed UI, and then you have it. But if your network is slow, then you might just have nothing on screen instead of maybe some things that were cached on the client. So that's a consideration. And then app binary size is another thing. If you go the server-driven UI approach, the client gets thinner. There is less things baked into it, so less client binary size. And then I talked about offline support that you need to bake into the client if you need it. performance considerations for complex animations, and then development complexity. Client-driven UIs are like easy to start with because you can just do it on a per-client basis. Server-driven UI is more powerful for some use cases once you get there, but there is an initial upfront cost. So keeping your team structure and considerations in mind is good before you decide when to use it. But you don't have to have an entire app in one versus the other. You can use a hybrid approach. Neither one of them is really a silver bullet. You just have to consider for various screens and use cases which one might work better and where you need things like offline support or complex animations. So the best way to start with server-driven UI, if you're interested in designing such a system, is identify a few main use cases. So for example, the listing page of Airbnb was one use case that they identified. So pick a use case where you know you want to A/B test the UI pretty often, or you'll be changing it, but it's also without like complex animations. Build a good system, design your data model around it, make good generalizations, and then once things are working for those use cases, then you can consider expanding to other screens in your app. But once you get there, the rapid iteration is great, and then also you don't have to be waiting for users to update the app. So yeah, that was it. That was an overview of what server-driven UIs are and how to get started if you're going to design one. Thanks.
Wait. Hello. I have one question. Is that what DSL do you use to develop your SDUI page?
Sorry?
The DSL, the development kit.
I mean, that depends on what your serving code is. Like all of the examples that I found for popular things kind of develop their own system. Mm-hmm. So yeah, I mean, you're just writing serving APIs that you can send to the client. So.
Okay, thank you.
How have you handled localization in SDUI in the past?
Yeah, I mean, I guess there are a few ways you could do it, but you might have to send some things in the request API that indicate like language and maybe locale that you need, and then that can be used to localize things on the server and just send it back. So I think that's like probably the cleanest way to do it. Yeah.
Hello. Thank you so much for talking about SEUI. I was just wondering, how do you recommend working with locally handled actions? Like, say, actions you don't want to really wait for the server to bring back a response. Probably a good example of it is if you have content and you want to favorite it. Maybe you don't want to do the full round trip response for it. You want to maybe update the UI real quick. Maybe it's somewhere else in your app.
Yeah.
And then eventually, just get that parity with API.
Sorry, so you just want to do an action completely on the client without waiting for?
Exactly. Like maybe you have something like a favorite button, right?
Yeah.
In a content.
Right.
And
okay.
you want that to maybe show up in a favorites list, right?
Yeah.
Inside of your mobile app. So maybe you don't want to wait for server to send that request to the server and then update your whole UI. Do you have any recommendations on how to handle that?
That's a good question. I guess I mean, you could have things that are like not server-driven UI, and you do that, but or mm,
I guess the question
mean-
is also, do you think it breaks the paradigm if doing things like that?
Yeah, I mean, like, ideally, most server round trips, if you have an entire SUA page with like response payload compression, like, shouldn't be that slow. So it should be okay. But like, you can speed up that round trip by maybe, so if you like save something and you want to update the thing, you also maybe need to make a call to some backend to actually mark it saved. That can be async from the server, and you just like send the response back. You don't have to block on actual state updates. So yeah, that's a thing. And then for individual like you know the Lego block components, you can attach action handling so that just that component is updated, and you maybe don't have to update the whole page. So it's kind of like how you break the page down a little bit.
Thank
Yeah.
you.
I have a question about the whole screens or navigation being backend driven. You have shown an example that where there was a screen ID
Yeah.
on the action. So it means that we have a one endpoint, right, which returns whole screen.
Yeah.
And any action that is coming from the backend side as a server driven may lead to the some generic screen. So, like, what do you think about it? Is it
Wha-
generally used approach or kind of anti-pattern?
I mean, open screen is a very simplified version of an action. Like, screen ID would be unique. So, for example, you say screen ID for like settings page, and that specific instance of open screen should open the settings page. So, like, the screen ID is tied to what the screen is.
Okay, so
That's how you
screen ID
make it
is
more
kind
smooth,
of
yeah.
handled on the client side to
Uh,
open this screen.
Like, yeah, like it's sent from the server if your screen is, that way. But the actual handling it's just like you send an open screen, like just definition in the response, and then client implementations will actually have to write hooks to handle it.
Okay, it's kind
so
of
yeah.
deep link, right? It can be deep link, like can handle.
Sorry?
It can be a deep link, right?
Yeah.
Yeah.
So, yeah.
My question is like, what do you think about like make it even like backend driven, like server driven? Have one action that opens a screen, and that screen calls the server for the response, and whole components come from the server.
Yeah, that you can do that.
So
Yeah,
this is not
that's-
anti-pattern, you think, right?
I mean, yeah, that's kind of like depends on what the use case is. If you're willing to wait for another round trip for your new screen, then yeah, you don't generally. I think that's how it would work. You wouldn't send entire data for the new screen with just the open screen action because you don't need it until someone opens it. So yeah,
Yeah.
yeah,
This is exactly what I wanted to say. Yeah.
yeah, you can do that. I don't see why not.